Hello and welcome to this webcast on adding Hadoop to your analytics mix, challenges and strategies. My name is Paul Barsh. I'm a marketing director for Think Big, and I will be moderating our big data presentation today. Now, it seems like, if you read the trade press, that everyone is excited about Hadoop. And there's lots to be excited about, especially all the Yarn applications on top of HDFS, such as Presto, such as Spark, and others. However, downloading free software, buying some commodity servers, or firing up a cloud-based Hadoop instance, that's actually the easy part of a Hadoop project. The more difficult stuff is organizing your company around the concept of using analytics on Hadoop, understanding what capabilities you want to focus on first, and getting on the same page in terms of data governance. That's the tricky part. So today we're going to show you strategies to expanding analytics on Hadoop, how to overcome organizational and other obstacles so that you can succeed with your big data initiatives. Our webinar today is led by Madina Kassengaliyeva, Director of Client Services at Think Big. At Think Big, Madina has led strategy, engineering, and data science engagements in a variety of areas, including recommendation engines, customer interaction optimization, marketing analytics, and compliance. Madina holds an MBA from the University of Chicago and a Bachelor of Arts in International Studies from American University. And if you don't know who Think Big is, Think Big provides data science and engineering services, including big data roadmap, data lake architecture and implementation, analytics solution enablement, and ongoing solution support. Now, before we begin our presentation, I want to bring your attention to some of the areas on the webcast console, a little bit of housekeeping here. You'll notice a Q&A widget. I encourage you to ask questions as they come to mind throughout the webcast. We're going to address some of these questions at the close of the presentation or email afterwards. So if we don't get to all your questions, we will get to them via email. There are also some icons at the bottom of your screen to explore. There is a resource links icon which will allow you to learn more about the topic at hand. There is a share icon which will allow you to send this webinar's details as it's ongoing to a colleague in case you find it interesting. We hope you do. And there's also a help button. This is an important one. So if you need any assistance with any technical issues, your slides aren't advancing, the audio's not working, anything like that, please raise your hand using that help button and we will address your issues right away. And this is a commonly asked question, but we will also be sending out links to this webinar replay in a follow-up email. So stay tuned for that. So before I turn the webinar over to Madina, we want to run a quick poll here. And the question is, what is your number one challenge with adding Hadoop to your analytics mix? Is it skills? You don't have enough or the right skills to succeed. Is it poor organization? You're not organized for success. Is it you don't know what to do first with Hadoop? You lack a strategy or roadmap. Or, this is a common one, our data is a mess. We lack consistent taxonomies and reference data. So which one is it? Let's see what the results are. Oh, it's interesting. We have quite a few folks on skills, but also we don't know what to do first. So we lack a strategy and roadmap. All right. So with that, welcome Madina, and thanks for participating with us today, and the floor is yours.
Thank you, Paul. Wonderful introduction. Good afternoon or good morning, everyone. I am assuming we have folks across different time zones, and thank you for joining us for an hour. I really hope this presentation is relevant to you, valuable, and certainly stimulates kind of follow-up discussions and conversations in your organizations. Let's just go ahead and jump right in. The way this presentation is organized is I'll talk a bit about where we see a lot of the challenges that are highlighted in the presentation, and that will kind of introduce and set us up. And the organizations may be there already or may not be, but either way, it's kind of useful to think ahead about these. And then we'll look at 3 different areas where we have observed our clients struggle through them, particularly as they get into kind of some more sophisticated usages of Hadoop. And then we'll go through these areas. I'll highlight some of the common challenges and then some of the ways in which we and our clients have thought about addressing them, and give you some client examples. And please do ask questions, as Paul said, as I go along, and we would be happy to address them either now or by email later. All right, so let's just get started. So interestingly enough, Hadoop it's a technology, right? It's a platform that gives us some new capabilities. And we see various ways of adopting Hadoop by our clients. This is a very common one, the one that I'm highlighting here. And it usually starts because there's kind of a pressure point, a pain point, that Hadoop can alleviate. Oftentimes, it's to reduce data warehousing costs, or it's to serve as a place for kind of either dumping historical data or as a way of speeding up ETL. We have one client in financial services space that went from ETL of their clickstream data running for up to 22 hours using traditional technologies down to 2.5 hours using Hadoop. And that clearly makes it much more impactful to be able to get prior day's data to your analysts much, much faster. So again, oftentimes we start with a pain point. Something has to change now. Things are unbearable, so Hadoop is often a solution. After that, what happens is as one data source gets landed in Hadoop, our clients often want to expand the scope of the data. So they will pull in other data sources, and that's when we start getting into the notion of a data lake, right? How do I bring together different data? How do I deal with increasing data variety, the fact that data is at a state that's less processed and a bit more raw, perhaps less curated than what the organization has typically worked with? How do I establish initial data transfer, governance, security, et cetera? And the interesting thing is that at stage 2, Hadoop is still perceived as large data technology platform. It's usually operated by enterprise infrastructure or a technology group, and it's kind of less known and less familiar to the parts of the organization outside of technology. Then something changes. We often see that it's either because there's a business unit that has a particularly close relationship with technology, or a group of data scientists or analysts that sit within technology that actually start working with that data. So you've now shifted from Hadoop being a tech platform for data storage and processing to Hadoop becoming a source of insights, a source of potentially new information. And we usually see that 2 to 3 teams get spun up and created to conduct proofs of concept, pilots, etc., with really the goal of understanding the data better that's in Hadoop, understanding how it can be brought together now across data sources, now that you've got them in this common environment, and what can it do? What are some new insights? What are some early wins that can be derived from that data? And an example of that, again, we did a project with a client last summer where we took clickstream data and we derived a series of new variables from that data, variables that were not available to the analytics teams before. And then we evaluated the impact of those variables on a single model. And obviously, that's not going to transform the way that organization does predictive analytics, but it did provide a very clear directional indicator that there's value in this less curated, less aggregated version of clickstream than before. And that's when excitement starts to build, right? These stories eventually leave technology. People start talking about Hadoop and the data that's available there to each other and to others. And if the impact truly is positive, right, that very quickly gets translated to a large promise by the more executive team in the company. So it's in that transition that we move from Hadoop being a tech platform and a fairly niche area to everyone wanting to use it, and everyone wanting to have access to the data in Hadoop, and everyone wanting to find new insights and build new models and so on, and shift a lot of their current approaches and processes to Hadoop. And it's also an area where a lot of promises get made. All of a sudden, you end up with exponential growth and or significant cost reductions and so on. But these are promises that are still based on an assumption that the projects now slated for Hadoop can actually be executed. This is the tricky bit. Once you get to stage 4 and Hadoop is actually integrated as part of your analytics capabilities, it's a well-known and well-established platform. Access patterns are well-established. Data is known. There are teams with a variety of skills that can work in Hadoop while still maintaining their ability to do statistical analysis that doesn't go away just because you now use data in Hadoop, and their ability to use the scalable technology and the advantages of it. That's when you get to the happy place, and Hadoop becomes almost, just like any other new technology that you've added to your organization, it has now arrived, and it's a commonly accepted part of your infrastructure and stack. It's the transition between 3 and 4 that's quite painful. So let's dig into that a little bit more. An alternative way of looking at this path is to focus on this critical point where, again, we have platforms and data, we conduct some proofs of concepts, there's some value, and then companies usually start rolling out a broader range of pilots using data and using Hadoop and other related technologies, and they want to move quickly to production. Right? This is great, we built these models, we love what the data in Hadoop and the scalability is doing for us, let's just go ahead and deploy it, which is fine. That's a technology track, and that most companies know how to do that very well. The challenges really lie in the top part of this graph, which is to be effective and actually make a new technology like Hadoop truly part of your infrastructure and truly a useful tool throughout the organization, you need to do the part on top. You need to do the capabilities and the tool selection and perhaps even reorganizing the way your teams work. So with that in mind, we will focus on 3 topics today. We'll talk about the organization and the challenges that we see in the organization, and obviously this is not an exhaustive list. We'll talk about capabilities, right, and some of the challenges we see in both defining the capabilities as well as actually building them over time, and we'll talk a bit about the data. So organization, what are some key challenges? Skills, roles, and responsibilities. And I think as the poll clearly showed us, this is an area where that's a significant pain point. Right? There's usually a skills gap between the skills you have now and the skills you need to work with data and Hadoop effectively. And that comes from the fact that, realistically speaking, most analytics historically has been done using SAS on structured data. So you have large teams of 50, 60, hundreds of people who are very, very good modelers on SAS, structured data, maybe expanding as far as using something like Greenplum as an MPP environment for scale. But there's this gap where there are kind of hardcore engineering and technology skills that are needed, and then there's skills of understanding new analytics methods that are available, such as if you typically work with structured data, even if it includes text, you're not actually doing essentially a lot of text analysis. Right? Hadoop potentially opens that up, and now that data is available to you, but maybe you don't have enough people or anyone who can do that kind of work. The other gap here is also everybody gets excited about it, and then we've often seen that once you start getting into kind of big data technologies, there's a bit of a breakdown between the traditional division of labor, if you will, where the business does the business and they do business-focused revenue-generating things, and then technology does technology and engineering. That line starts getting to blur, so it's becoming blurry, and we have a lot of clients who create data science teams, essentially in both technology and in business. And that can be very confusing when it comes to then how do we divide responsibilities, how do we work together, who is still on point for what, especially as we're trying to quickly move through innovation to production. And clearly here, throw over the wall just doesn't work. You're now talking about new data or data in a new state. You're now talking about new analytics techniques. So you can no longer say, technology, go build me that, because what they come back with may not align with what you actually wanted, and the other way around. Technology needs to be very aware of what are the real questions the business needs to answer. So breaking down that wall and barrier becomes really important. The other aspect of it is lack of common vocabulary. We generally, and this is actually, I've literally been in these meetings where people use the same words for very different reasons, and they have very different meanings, and we don't talk about it. Now, one of our clients asked us to create a roadmap for them, and I'm using an example, kind of a more scrubbed example of it actually in this deck, but they asked us to create a capabilities roadmap for advanced analytics. Well, people didn't agree on what a capability is, which ones do we need to highlight, and how do we talk about it? So getting to common vocabulary across core groups that would be using Hadoop is really, really important. I would argue it's as important as having your metadata for the data in Hadoop in place. Knowledge capture and sharing, that's obviously a big one, and it gets more and more painful as you have more teams working in the same environment. There's value in learning, and your teams are probably now doing things that are new and less known, and somebody can run ahead on particular techniques or understanding of the data, and it's really worth just capturing that. And unfortunately, because of the organizational silos, we tend to keep technology information within technology and then business information within the business, and then maybe analytics teams are on their own too. So that organic knowledge sharing that is also part of the, kind of to go back to skills, roles, and responsibilities, also part of this kind of we need blended teams problem doesn't happen as well. So what do you do? Just a few ideas, and obviously these are ideas we've tried with our clients, and for the most part they work. Obviously it depends on how things get implemented in your organization. We believe very strongly that having senior level, executive level support and sponsorship is critically important. Organizational change is hard, and a lot of it can happen at the grassroots, but it has to be supported by almost a fundamental mandate from the top. So we often recommend our clients that they kind of formalize a cross-business unit committee. They often have them already. There you'll have your data strategy group, or your architecture group, or your SVP of marketing who is closely aligned with SVP of technology, but formalizing that group and giving them a mandate to drive change can go a pretty long way in making that change actually happen. An honest and thorough skills assessment. And again, this is a murky labor market. Just as it's a murky technology market, the murky labor market also exists. We've all heard the jokes about a data scientist and statistician under 30 who lives in Silicon Valley. That is true to some extent. But moving away from traditional role definitions and moving away from labels and expecting that everyone who has the same label has the same skills and competencies becomes really valuable here, because the way that you'll be putting together teams to execute your project will probably get more granular than just saying, I need a statistician and an engineer, right? So doing a very honest assessment of skills you need for the kind of work you want to do, and frankly, consultants who do this kind of work can be helpful here because we put together teams like that. We train our people. So we have a pretty clear idea of what are the competencies that people on the teams actually need to have, and then bumping that against what you already have. And again, you may very well have people with all the right skills, probably not enough of them. So thinking through the training curriculum and a growth path, and how do you transition those people who have the foundational and the seed competencies to kind of uptrain them on new skills is usually a worthy investment of time if you want to create kind of a skills base for the long term. Documented tools requirements based on current and projected skills. Again, particularly because with Hadoop, there's often a slew of other open source technologies that are very, very exciting. Right? Everything from Spark to R and Python, which are probably more accepted, but work a little bit differently on Hadoop, right, to any number of open source, especially analytic tools and options and languages. And people get really, really excited about wanting to use them, which is fine and great, but let's decide what tools we can actually use now, right, that allow us to take advantage of some of these newer technologies, maybe not fully, but substantially, right? And what tools do we want to be able to use, and what does that mean for skills? Because that will allow you to lay out not just your kind of skills roadmap, if you will, your skills curriculum, but also your tools roadmap. And create some alignment there so that you don't invest too early in tools you don't need and nobody can use, but you also don't underinvest in tools that will ultimately be valuable. And then lastly, just to jump into the last two things, collaboration architecture, right, putting in that kind of not just technology architecture, but if you will, organizational architecture that encourages collaboration. And then using the existing knowledge transfer tools, but removing the organizational silos. It is okay for people in business to be able to look into the SharePoint site of the technology group and the other way around. All right, let's move forward. Just a couple of examples. When we talk to our clients about capabilities, we often create this functionality heat map. And what you'll see here is we'll look at key functions that the organization needs to have, and these are not organizationally aligned necessarily. They don't have to be in the same business unit, but they are overall the functions that multiple groups may need to have together, and we usually map them to their levels of criticality. So there will be functions that, based on where our clients are now, need to be addressed in 0 to 6 months, 6 to 12, and so on, and which ones they already have that are working well. And so just a little example from one of our deliverables. So let's move forward and talk about capabilities. Right. And again, capabilities is this really broad notion. We think of it as competencies are skills and abilities that people have. Capabilities are what organizations can do, what business units can do. So capabilities are usually conglomerations of competencies. And you need to think about which ones you need, when do you need them, and how critical are they, and if there's kind of dependencies between them. Because again, that will also help you define what skills you need, right, and how do you develop those skills. Unfortunately, with capabilities, there are some that we deem foundational, and we'll get to that in a couple of slides, so an example of what we think of as foundational, and then there are others that are specific to a function, an analytics function or an engineering function and so on, or a business use case even. The trouble with foundational capabilities is that they're not very sexy, realistically speaking, right? It's things that you just kind of have to do. They're still several steps away from delivering business value and having a frontline impact, and as a result, they often end up at the whim of changing business priorities. If you have a team that's supposed to be working on foundational capabilities, and then someone comes in from the kind of executive team and says, you know what, we really want to invest in artificial intelligence, and you know that's your A team, that team is probably now going to be working on artificial intelligence, which maybe you do need. Maybe you don't need yet. Maybe it's someone's latest idea. So because foundational capabilities and teams that build them often end up at the whim of priorities, it takes our clients much longer than necessary and probably a much more painful way to actually establish those capabilities. lack of consensus of what they are, right? What do we consider foundational? Why do we need them? What do we get out of them? And how do we show that they're valuable? And then this is what I was alluding to earlier, is the top project changes and the resources go with it. They go to the top project. And then lastly, speaking of capabilities, the future that's hard to envision is hard to build, which leads to lack of shared vision. You often have business teams laying out their strategy and plans for a year or 2 years, and you have technology teams doing the same. They rarely do it together. In fact, one of our offerings at Think Big is what we call a roadmap. And that roadmap, pardon me, I'm just going to scroll back a sec. That roadmap actually allows our clients and almost forces our clients to have conversations across org silos and agree on all of the capabilities across different business units. So what do we do? And again, this goes back to my earlier point about needing to have leadership. Consolidate ownership in a team, and that team needs to have representatives from various places, your business, your analytics, architecture, data, because they'll know where their individual groups are going and how those paths should come together. Create a common vocabulary. Agree on what you mean by capabilities. Agree on what you mean by foundational capabilities. And those definitions can change as your conversations evolve, but it's important that as they change, that those changes are known, and everybody, when you're having a conversation, you're all on the same page. And then create roadmaps. We have clients who really push back against roadmaps and say, no, we've had consultants come in and they build a roadmap for us and it's completely useless. Okay, well, there are various reasons for why that didn't work out. But in our experience, if you approach a roadmap in a collaborative, cross-functional way, back to this team up front that has representatives from various parts of the organization that understand their individual areas, the roadmap can be both a useful exercise to go through so that you can do a bit of the storming and then eventually kind of come to a common conclusion, right, and reconcile the differences and reconcile the conflicts that you may have, but also becomes even a high-level path forward, which is useful when having conversations with others and somebody asks, well, when are you planning to do analysis of third-party data in Hadoop, and if it's on your roadmap, you have some way of answering that question that's actually reasonable and thought through. It also allows you to see gaps. Where you could say, okay, for us to execute on this use case that's very high business priority in Q2 of 2016, we actually need to have all of these technology capabilities and these skills on the teams and these data sources available in our Hadoop environment. And how are we going to get to that? So putting it all in a single roadmap that aligns use cases to technology, to data, and to skills and capabilities gives you that kind of a comprehensive picture and essentially marching orders. And then, I can't stress this enough, dedicate resources to capabilities and protect them. Acknowledge that you'll have a team that's really focused on building the foundation of your house. And that team needs to focus on that. And realistically speaking, if they do, they'll probably move faster, they'll have much greater learnings, and that will accelerate and potentially even reduce the cost of everything else you do after that. And check with your roadmap once in a while. Does it still reflect your vision? Probably checking in a couple of times a year is a good idea. Things have a tendency to slip and slide, and some things get done faster and some things get done slower. So looking back and saying, are we on track? Do we need to reassess? Or are we behind on something that was critical is quite useful. And again, it doesn't need to take a lot of time. It could be 2 days of an offsite or a workshop with an assigned facilitator to go through this exercise. All right, so this is just, again, a couple of examples. When we think about capabilities, we often stack them as a pyramid. And because the model of working with Hadoop often includes both exploration, which is let's go see what's there in this new data set or in this new version of a data set we now got, or what happens when we combine these 4 data sets and apply the results of it to our models. So that's the exploration part. And then If things go well in exploration, we can move things to production, and that's the top part of the pyramid. And the capabilities you need across these two are quite different oftentimes. Production is much more about automation and systems monitoring and performance monitoring and kind of ongoing measurement, while exploration is much more about working with data in new and creative ways, kind of really getting your hands on it and not expecting specific results, right? You almost manage your results from production differently from your results from exploration. But when we refer to foundational capabilities, it's these aspects that are here: data access, storage, data transfer, ability to do statistical modeling and machine learning, ability to do data wrangling are critical. You cannot do the data exploration and creation of new models unless you get these two bottom layers right. And this is just an example of a high-level roadmap. And you could also expand this to include data sources here, and then with data sources define if you mean data sources in Hadoop or accessible from Hadoop, or ongoing ingestion, one time, et cetera. All of those details can be worked out. But here we really talk about integrating data science. And by that we mean data science is done in Hadoop and as well as analytics that are done in more traditional environments. So how do you bring them together? And then how do you kind of operationalize and move this to an overall integrated production pipeline, if you will? So what gets processed in Hadoop? How do we integrate with existing scoring engine? What kind of modeling and scoring do we do where? A lot of our clients are now looking at real-time capabilities and this question of what do you score in real time, where do you do it, and how does that change the way in which you do modeling and monitoring is very important. So again, this roadmap, it's nothing that people haven't created before, but if our clients actually agree to it and they look at it and it usually has a timeline, you can say, oh, we're tracking or we're not, or we thought that we wanted to do batch data processing in Hadoop, but we've actually found this different workaround that works better for us. Or we were able to scale up and now our teams can actually go to Hadoop directly and pull the data they need. We no longer need to move it to a more traditional environment. That's all fine. So this is an area where you can make updates. And then you have obviously certain operational aspect because we are all talking about enterprises here for the most part, and you can't just have people accessing and working with data willy-nilly. So you have your data ingestion and security and metadata management aspects of just working with the data, and we'll talk a little bit more in Section 3 about that. Data management and model management become really important, especially as you are now creating models across different parts of the infrastructure. So let's say some in Hadoop and some in SAS. Having a robust framework for developing them, measuring their effectiveness, deploying them, and then monitoring them over time becomes even more important because you need to be able to either retire models that are not working or see when a model goes awry and it's doing something it's not supposed to, especially if you move closer to real-time analytics. We were joking with a client about it last week where we said, well, our goal should not be to deliver bad experiences faster. So model management and quality control become really important. Okay. So moving forward to Section 3, data challenges, right? And there's kind of, it's a very interesting thing about Hadoop because a lot of people get excited about it because they say, Hadoop can accommodate so much data and such a great variety of data, right? And you can literally dump it all in, right? One of the common languages used in Hadoop is pig, and the joke about pig, or what people say is pig eats everything, meaning it can work with any data, which is really exciting. And it's what allows us to do some new and interesting ways of data analysis, right? It allows us to do new types of text mining. It allows us to bring together data that we could not bring together before, which is a lot of that where insight and value lies. However, you still need data schema. Just because data schema is no longer defined on write, as in when you put it in a database, which is what you typically do in a traditional database environment, it still has to be defined. Unless data schema is defined, that pushes the responsibility for defining the schema. How do I want this data organized? Right? To the end users, who, as we discussed earlier, oftentimes don't have the skills to work with this infrastructure, and therefore probably don't have the skills to know what data schema they need. And you're also talking about data that's potentially completely new to them. So just consider the impacts of that, and that not everything goes rosy here. We talked about this when we talked about metadata management. Consistent taxonomies, having reference data, are critical for to be able to do meaningful analysis. Right? People have to know what a field means, and that definition has to be consistent. This gets particularly interesting in Hadoop because you're bringing in so much new data, potentially data from outside, that has not been curated necessarily as thoroughly as your internal data is curated. It also gets interesting when people start combining data and creating kind of new extractions and new data sources out of it. And because that work is often done as part of exploration and almost research, there's usually little rigor put around documenting the results and publishing a data dictionary, all these things that we're all very familiar with in a traditional environment. But because this environment is new, some of those kind of commonly accepted rules seem to be less valued, at least temporarily. And then keep in mind that reference data changes. This is particularly interesting in financial services and kind of market data, which we often work with. But if you want to do, let's say, a broader scope of portfolio analysis and allow your customers to see how their portfolios did, not just this year, but 3 years ago, or how their portfolios would have done during the 2008 recession, and just allow them to model that, that means you have to go back and pull not just transactions and positions data, but market data as well. And guess what? Market data, security identifiers change, right? And being able to put that data together and link it together and see where it changed and what it used to be called and or identified as becomes important. So reference data changes in a variety of industries. Financial services is one where it actually often matters. So, and just kind of last couple comments on architecture, right? When we talk about access and patterns and flows, and we'll chat about this a bit more when we get to solutions. Understanding where the data, where does it come from, how often does it get there, how is it organized once it's arrived, how do we monitor its quality, preferably in a way that's automated, so that you don't have teams that spend their time, literally counting rows, right, and columns. Become more and more important just because you've now increased the variety, you've now increased the volume, and you've often increased the frequency of updates. So more things can go wrong, and they're harder to monitor. And then really making decisions about what should be done where. Not everything has to be done in Hadoop. When we think big, really believe that big data technologies should become part of your infrastructure, part of the solution. But it doesn't mean that you throw out everything that you've done before and ask everybody to retrain and move everything. That's just not right. So deciding what's done where, deciding where ETL is done, where data prep is done, where scoring is done, where modeling is done, where kind of measurement is done afterwards, is certainly a worthy investment because, again, it will help you identify gaps and areas of weaknesses and ask questions about, does our architecture and data flow map align with what we know how to do as a business, with the speed at which we need to make decisions and where we're going? So just a few, ideas. This is a big issue with a lot of opinions, right? Data lake is a perfect example of this. People are creating practices around putting together data lakes and maintaining them. And it's important because we all know the notion of garbage in and garbage out. Well, here you can create a serious, garbage pile that you're then trying to use to make good decisions. we recommend defining common data manipulation patterns and really thinking about your usage patterns. How will the end users or the analysts actually want to work with the data that impacts the way that data is organized? The other notion is also how can we make it easier for them to work with the data, especially as if there's a skills gap between what they know how to do now and what we need them to know how to do. So you can invest a bit in kind of a data engineering team that actually is responsible for data prep, if you will, doing common aggregations, doing common reductions, running basic statistical analysis, your counts and mins and maxes, can go a long way in enabling the people who know how to do the statistics and the analytics to work with that data early. Eventually, obviously, the skill sets will change, and the need for this will go down. This also, kind of common data manipulation, also helps support data quality monitoring, because if you have aggregations and statistical, your kind of basic descriptive statistics, you can actually monitor them over time and say, wait a minute, this table has historically had 13.5 million rows, or roughly so, and now its size has increased by 50%. Right? What gives? Why? So then that allows you to kind of raise a flag and investigate that and catch a data discrepancy early. Centralized responsibility for data governance, architecture, taxonomy, and maintenance. And again, this helps prevent gaps in knowledge and gaps in information, especially as new data gets loaded and new data gets created through analytics. Knowledge sharing for data. And this is really important because, as I mentioned earlier, new data sources get created, and those data sources may be useful to more than one team. So other teams should be aware of, we created this, we work with this data, and we created a data set that supports word cloud analysis, right, for the reasons our customers commonly call us. Well, that data set should probably be accessible to more than just the team that created it. And this is just a couple of examples of how our clients have gone about organizing data. We do have a data lake practice, but this is really an organizational example of a client that decided to centralize their data group. And again, the mandate came from the top that said, there's value in our data. We want to become a data-centric organization, and the way we're going to get on that path is by creating this cross-business unit, cross-functional group that has various responsibilities for the data. They are the data custodians now. So this group owned data management, knowledge, architecture, and quality assurance. This group also had people who could work with the data hands-on and start looking at the value of that data, at what new insights can be extracted from it and what impact does it have, as well as telling that story, those initial success stories to others in the organization to keep the excitement going, as well as to kind of build a broader base of support and advocacy and stakeholders for Hadoop and associated technologies. And then they were also responsible for data aggregation and enhancement. Just back up because I want to say something. Oh, come on. And I apologize. Go forward. All right, anyway. So as far as data aggregation and enhancements goes, to that last point, it is an interesting challenge because oftentimes there are certain groups that have the skills that can do the work, and they end up responsible for operational and production support, which may not be the right role for them. One of our high-tech manufacturing clients created this group that was really supposed to be at the cutting edge and do a lot of research and generating of new insights. But because they were the only ones who could actually work with data in Hadoop, they ended up also becoming the production data engineering team and the support team for all the new kind of data streams, data pipelines that they developed. That obviously meant that their time was no longer focused on research. It was now focused on production engineering, which defeated the purpose of creating of that group. So to go back to roles and skills and responsibilities and the organizational structures, considering the dotted line you need between exploration and capabilities involved in that, and production and capabilities involved in that may be valuable for you. There's obviously a need for a lot of knowledge transfer between those two groups, but allowing your researchers and the people who are building foundational capabilities to work continuously on that without getting pulled into the latest production problem will probably make A, that team more efficient, and B, that team probably happier, because we often talk about different skill sets and team preferences at those levels. So just to recap, organization, technology is not enough. And we've seen this and we've said this, where there are real technological and technical challenges, but those can be often overcome with the right purchases, the right architectures, and so on. But organizational change, whether it's kind of fundamental and complete, or if it's partial, and usually partial gets you a lot of the way there, it cannot be ignored, because your teams are now working in a way that is truly different from the way they've been working in the past. Executive commitment is key. This is going to be painful and potentially expensive and uncomfortable and raise lots of eyebrows. So having commitment and buy-in and leadership behind is very important. The capabilities, a couple of key takeaways would be, have the tough conversations early. Yes, it's going to be uncomfortable and people are going to argue and bicker, but ultimately should arrive, if it's done constructively, ultimately, with the goal of progress, to much better alignment early on. And that alignment early on will pay off, so that you spend less time spinning wheels and investing in things you don't need to do, or that are truly detrimental to you. Right, and dedicate resources to building foundational capabilities, just like in a house or any other area where you need a strong core that then supports everything else. And with data, centralized data management, people have to know not just the structure and the schema of the data, but what that data is about, and usually putting that into kind of a group that's responsible for it can go a long way, as illustrated earlier by one of our clients' examples. And then knowledge of the data means knowledge of the business, right? The more and more businesses rely on data and analytics to make decisions about everything from their long-term strategy to tactically extending a new business line, to moving to a new market, or changing the way that they provide customer service, right? And this formula goes both ways. Knowledge of the business now requires knowledge of the data, and knowledge of the data requires an understanding and means a thorough kind of alignment with the business. So that's what I had. I'm going to pause here and open it up for questions.
All right, Madina, thanks for that. So we had some questions come in, and now, of course, is an opportunity for you to use that QA widget and ask a question for the open Q&A time. So Madina, I'm going to paraphrase some of these, because some of them are a little hard to understand, but I'll try to take a whack at them. So one of them is about the cross-BU capabilities, so cross-business unit capabilities. Somebody's wondering, is that the same thing as a BICC? A lot of companies have been asked in the past to set up a BICC as a best practice. So is what you're talking about, Madina, the same thing as a BICC?
I think BICC can serve as a good model for what we refer to as business capabilities, as cross-business capabilities. But that doesn't necessarily mean that you need yet another BICC or Center of Excellence. Usually what happens is what we see our clients do effectively is that people will still keep doing their day jobs, if you will, maybe to a lesser extent, while also getting the responsibilities for this new area of technological change and resulting organizational change. So it's probably less formal than a BICC and more of a functional alignment than an organizational one.
All right.
Does that answer the question?
Yeah, I'm hoping. I'm looking at the queue here, and there's at least 2 questions on security. So, you talked a lot about the organizational processes and the data and all that stuff, but there's a question in here on, can you explain more about how security fits in what you discussed today?
Sure, absolutely. security in terms of, I'm assuming we're talking about security of data.
Yeah, I would imagine that, yeah.
Right. And that's an interesting one because you have this notion of, there are different reasons for security, right? You have security in terms of regulatory requirements and compliance, and that's probably the first thing our clients think about, right? How do we secure data that has to be secured, make sure personally identifiable information does not get leaked or go to people who are not supposed to have it. And there's lots of tools for that. You can secure your entire cluster. You know, Kerberos is a commonly accepted tools. You can secure specific data tables. You can secure down to specific data fields even. You know, tools like Podium and others do that well, reasonably well. I think the more interesting security challenge arises when you talk about derived data or data that's created by combining. So it could be perfectly well that there are 3 data sets that are individually innocuous and not revealing. But if you bring them together, you now have enough information to identify a person or to identify a market pattern that you're not supposed to know about, right? We have a couple of client examples. One was, and then this also goes to an impact to your brand, an impact to not just regulation and compliance, but truly kind of, are these things right to do just because you can't do them doesn't mean you should. So a couple of client examples here. One is we had a client where, and they're in internet security. So for them, this notion was very, very important. And we said, oh, wait, you can actually look at this data and predict corporate actions just by looking at internet traffic. And they said, okay, we got to shut this down, and we cannot do that because right, you now have all of a sudden visibility into markets that basically know what a few other people do, and so that's security too, right? That's something that is derived from your data that can have impact on your brand. And then another example for one of our clients had to do with HR, where a result of analysis turns out couldn't be openly shared because of its implications. So I think data security is probably more straightforward than securing the implications of your now newly available data analysis.
Yeah, that's a good point about the different elements being innocuous, but you add them all together and it provides a picture that maybe you shouldn't have. So that was good.
Right.
All right, there's one here on SaaS. So you ready for this one? It says, we have an existing large community of SaaS users with a large body of analytical assets. How does that situation impact the evolution that you're talking about to a modern data analytical platform?
Yeah, and that's very common. Most of our clients, certainly large enterprise clients that use analytics heavily, have a large community of SaaS users. Some of these challenges could be solved through technology. SaaS is obviously working on integrating with Hadoop. Right? It's very much in their interest, and this is not a line of business they want to lose. So there's kind of the notion of, can you have connectivity between SaaS and Hadoop? And that just truly means so that the people who know SaaS can go get data there. And again, here the areas to explore, I think, are one is, and we talked a little bit about this, about figuring out what you need to be doing where, based on the skills you have and on the skills you'll have in the future. So if you have a large community of SaaS users who are accustomed to working with more structured data, maybe creating a smaller group to do data exploration in collaboration with those SaaS users, because the SaaS users are the ones who actually usually understand the business and understand the statistics. Right? So creating a group of people who can work with the data in Hadoop and putting them on a team, on joint teams that are focused on specific questions or hypotheses you want to test, and having them do exploration together will yield 2 things. One is you've now made your SaaS analysts and their access to Hadoop easier, and usually it means hiring another 3-4 people, potentially something as small as that. 2, in that research process, they usually find what data they want, and then you can have a data engineering initiative or project to make that data, to create that new data set in Hadoop. So you essentially have new aggregations or reductions or whatnot, right? And you create data that's ready for modelers who are now can work with that data in SaaS. And that's a very common path we've seen our clients take. At the same time, most people who know how to use SAS can also use SQL, and a lot of people who know how to use SAS can use R. So we also often recommend to our clients and actually provide training around this, where SQL to Hive is usually a reasonable transition, and R to R Hadoop is usually a reasonable transition. So we would recommend, at least for a group of the SAS modelers, investing in that training and that upskill to make them more independent users who can work with Hadoop directly.
All right, here's a tough one. So, and maybe if we can't answer this one, we'll do it offline. But they ask, is it possible to run a dev test production within one cluster? And what are the performance issues and resolutions? I don't know if you've seen any of that in any of your client cases, or if we need to take that one off and answer that one later. What do you think?
Yeah, we may be better equipped to answer that one later. And I'll be honest with everyone, I'm not an architect, so and certainly not an operations architect. So when it comes to kind of performance issues and challenges, that's just not something I'm equipped to do. But a lot of our clients use the same cluster. They're usually often multi-tenant clusters, meaning there are different business units using them, and they usually use them both for exploration and as well as for production and operational development. It can be done, but again, their governance and processes and kind of gating factors become even more important. And usually as the organizations get more sophisticated and there are more and more kind of Hadoop-based projects, our clients end up investing in separate clusters for different purposes. Because you can do both exploration and production deployment if you have two groups using Hadoop. It gets harder when you have 20.
Okay. So I think we have time for one more, and this one's a little bit on the generic side, but maybe you can at least speak to it from what you see with your clients. But it asks, what are the classic pitfalls to look out for with data lake implementations? How do you avoid the pitfalls when you're trying to implement a data lake?
Mm-hmm. Yeah, and Paul, I think we should probably also do a follow-up webinar on the data lake if we don't have one scheduled already, because I think that's an area where we certainly get asked a lot of questions, right, and have formulated a lot of thinking. Common pitfalls on the data lake. Assuming that a data lake is the cluster, or that the cluster is the data lake, meaning that to create a data lake that has all this data you want there, you have to have all of it in one environment. That may not be true, and at least logical separation, if not physical separation, is probably worth it, especially when we think back about this notion of security. Right. The other one is kind of curating and maintaining your data lake. Creating a data lake is probably relatively easy. Creating it in a way that makes it easy to maintain so that it doesn't become messy is more difficult. And that's where agreeing on how you're going to do ingestion, agreeing on how you're going to do metadata management, agreeing on data structures up front is important, because the more and more data you move there and the more and more people work with it, without those definitions and processes and tools, frankly, that support it up front, we have seen data lakes get pretty messy, and then untangling them is quite an undertaking. So that's another common pitfall. Think about not just creating it, but how do you maintain it? How do you have that kind of pristine reservoir you invested a lot in still relatively at least pristine 2 years from now?
Absolutely. All right, well, let's wrap up with that, and thank you. So we had a lot of good questions today. Of course, if we didn't answer your question, there's a couple in the queue we didn't get to. Someone from Think Big will follow up with you. But that concludes today's presentation on adding Hadoop to your analytics mix, challenges and strategies. If you want to view this webcast at a later date, or maybe you came in a little bit late, there was a couple questions on how do we get access to the slides. Links to a recorded presentation will be sent to you via email if you registered for today, and also a link to the slides, because Madina is making those available. So that's good. And of course, your content widget at the bottom has some resources, so take a look at that before you leave. So on behalf of Think Big and Madina, we thank you for your participation today. Have a good rest of the afternoon.